Alright, so last week we stopped at here, the collision detection. We haven't actually talked about collision detection yet. So right now, when we are shooting the bullet, what happened is actually the health, the HP, actually reduced before the bullet hit the actual target. So you can see when I click, it is reducing the HP. But that's not the way we want. This is a fake. This is a very cheap fake of that shooting action. So what we want is we want this kind of HP reduce happen when the two objects they hit each other. When the bullet they actually hit the object, right? So we don't want this kind of cheap stuff. So let's see what we are doing here. So we use a thing called collision detection. So collision detection means we're trying to, in the virtual world, we're trying to detect whether two objects they have some overlap with each other. So if you're thinking about two spheres, it's pretty easy. You just need to calculate the distance, first the distance between the two spheres. And you calculate, and then if that distance is greater than the radius, so we can say that there's it's greater, the distance is greater, so there's no collision there. However, if two spheres they actually hit each other, what we can tell is the distance is pretty small, and it's smaller than the sum of the two radius. So that's pretty easy, but that's the theory behind the collision detection for the sphere. And also we can do collision detection for a cube, okay, for a box. That's our mathematically calculated through the computer and some theory behind it. So box is a little bit more complicated than a sphere, you can see. And also the most expensive collision detection is if you have a mesh collider on your game object, like a human, right? If you're using a box collider for me, for this human, okay, so if you think about a box which covered me, the height, the width, okay, yeah, if you hit here, it can be detected. However, if you hit here, at this place, like just behind, just above my shoulder, somewhere here. This actually, my human body is not here at all. But still, since the collider is set as a box, right? When the bullet hit here, it still reduce my HP or reduce some other things, or the character dies, something like that. However, but that's not the way we want. For some of the game, we want a very accurate collision detection. Then we're using the most expensive mesh collider. Mesh collider is actually matches your model exactly according to the mesh of your model. So the finger, even if the bullet goes across the finger, if you are using a perfect mesh collider, even the bullet go across between your finger, it won't count that as a collision. So, but there's a trade-off there. So sometimes we want to shoot the target. You don't want to be that accurate, especially when you're running a cheap game and the game wants to reduce the resource, and it's not very accurate simulation. Maybe in military you have a shooting simulation, you want that to be pretty accurate. but sometimes in the game we want it to be cheap. So it depends on what kind of application, what kind of environment and game you are developing. You have to make such kind of decision. So the box collider is not accurate, but it's cheap. It costs less of your computer resource. However, the mesh collider, it is pretty good. It's very accurate, and it simulates the real world very well. However, it's too expensive, so you have to make such kind of decision when you are selecting the collider. So here, before we are doing collision detection, here we are using a collider. It is pretty straightforward because this is a box. This is actually a cube. So we use box collider. Yeah. This component is called the box collider. So yeah, a box collider for a cube is actually what exactly as the mesh collider for that cube, because the cube is a box. Right. And here for the box collider, you can actually adjust the center, the size of the collider. Let's see if we adjust the center. See, the collider is here. So when you set up the collider away from that object, okay, this is no. So here actually we have a green box collider, but it's hard to see. Okay. So actually I can move the collider here, but still leave the box here. So at this moment, if the collision detection will happen over there, there's a offline of a box there. So whenever you hit that object, collision detection the collision won't be detected. But if you hit that collider there, the collision detection will be triggered. So it all depends on the collider, not on the object. So yeah, that's the idea here. But usually we are not doing this. We put the collider actually merge with that object. So usually you don't want to mess with these parameters. Just 0, 0, 0. That's the center. Make the center of the collider match the center of the object. Okay. Okay, so we actually have a collider here for this box, and okay, the yellow one. Let me see what is our projectile. Okay, this is our projectile. So for this prefab, you remember prefab? Yeah. So prefab is something we created, and we want to save it as maybe a template or something. So we have a prefab. The prefab object is not in the hierarchy, game hierarchy. It's not in the panel. You cannot find it. It's not in the game scene. Instead, it's here. It's in the assets. It's actually an object in your project folder. It's not there in the thing. So for this sphere projectile, it's actually a prefab we made for the bullet. Okay. So it also have a collider. So that's a sphere collider. Sphere collider. So when we are doing this kind of collision detection, it's actually detecting the collision between the sphere and that box. So it's relatively very cheap collision detection, but it works pretty well here because we have two objects. One is sphere, one is box. So that actually looks like just like a mesh renderer, the mesh collider. Okay, and so after we detect the collision, so when after you set up the colliders, you want to program what is the reaction for that collision when the two objects they hit. When there's a hit, what's gonna happen? So what we are doing is we actually put the, where do I put it? On collision enter. So this is that script. So in the script I've tell you that we have an update function, right? But here we're not using the update to detect that collision by ourselves. We're not detect the collision. We're not implement that because that's already implemented for you. What you need to do is just tell the system what is the reaction after the collision. So this function on collision enter, you're gonna override this function. This is actually a function for this mono behavior class. So okay, yeah, you need to override this function in order to tell the system what you're going to do after the hit. So what we're doing is here debug.log hit. What it means is it's actually having some output information like print, like what you are using in a Java and C++ print. Okay, so it print a word hit in the game, in the console, not in anywhere in the game scene, in the console, and it output the name of the game object. Yeah, and then it's reduce the scale of the health bar. Scale minus equal to 0.2. So every hit we reduce the scale. We reduce the scale of the health bar by 0.2. And so 5 times, if we hit 5 times, then the health bar will disappear, something like that. Yeah, and then we gave this new scale to that health bar. That's basically this for statement. That's what this for statement do. Yeah. So these two are output some information, some info here, and here is a reset. These two, they're resetting the scale of the health bar. Yeah. So that's how we implement that void on collision detection. So where do we attach this script? Yes, here you also need to tell the system where is the health bar and where is the what is the original scale of that health bar. So that's all the script did. And where do we put this scale? Let me see. right now it's still fake, right? Yeah, it's still fake. So I need to first remove the fake thing. Is it in fire? No. I think grease 3D. Yeah. Okay. So it's here. See this if block? It's a fake detection. So when we press the button, fire 1. Actually, I defined fire 1 here. If you remember, I defined fire 1 here in this input. So I'm mapping the fire 1 to the mouse button. Okay. So if I detect the button press for the get button, fire 1, and if another condition is if its current health greater than 0, so we reduce the health and we change the bar. Change the bar is here. We reduce the scale of that health bar. So let's remove this. We're not doing this anymore. Let's comment this out. Let's see what's happening now. See, it's not doing anything. Even there's a hit. Okay. So what you will need to do is attach this script we just mentioned, object collided, this script to this box. You just need to drag it here. And here, see, we have a public variable which is called health bar, because we are here, we set up the collision detection script attached to this box. However, we don't know where is the health bar of that box. So we need to tell the script which object is the health bar. So we need to set it here. Set it here. It's okay. Health bar. So the health bar is this quad. Okay, so we kind of need to drag this quad. No. We need to did I just remove that? Okay. We need to drag the quad here. Alright. So right now it's a health bar. Health bar is a quad. And the collision detection is on this box. Let's see what's happening here. See? So when I press the button, nothing will happen. However, when it hit that object, it'll be reduced. The bar will be changed. Okay, it's gone. So that's how we use the collision detection here. Okay, let me see if there's anything else I want to explain here. The health bar. No, that's a object collided. Yeah, that's a collision detection. Okay, that's another script. That's how we actually fire the bullet. This is script how we actually fire the bullet. It's very short amount of code, right? So what we do is I can't remember if I explained it in last class. So we instantiate the prefab with this code. We instantiate the bullet prefab and with the new vector, which define the position of that bullet, and the transform rotation. That's the orientation of that. That's the orientation of that bullet, and as game object. So we instantiate that prefab as a game object. That's the basic logic here. Instantiate prefab as game object, and when we instantiate that prefab, when we instantiate this bullet prefab, we also set the position of the bullet, and we also set the orientation of the bullet. That's basically how you use this function. And here we have a destroy. Why we're using destroy is the game object, like bullet, you can shoot maybe 1,000 of them in a game. However, we don't want to keep all of them. Those bullets, they just came into effect for a certain amount of time. If it's fly far away, sometimes it won't make damage to anything, so it won't change anything in your game, in your environment. So we want that to disappear, and we don't want to render that. We don't want to have any calculation update function on that anymore. So we can use this function, this destroy, instantiated projectile 2 seconds, after 2 seconds. So that bullet will only exist there for 2 seconds. So in another word, if you shoot a bullet and it's flying very slow, it will, like, according to that speed, it will hit the cube after 3 seconds. So if that is the case, you need to increase this 2 seconds here. Otherwise, you won't see that hit, and the hit won't be detected. So you have to adjust that according to maybe the different situations. Okay. Yeah, that's what we're going to talk today. Okay, so that's how we create that. Alright, so that's what left over from last time. Now let's go to today's topic. So today we're going to talk about something like, it's called expandable item class. Expandable item class. So what exactly is the expandable item class? So in a game, usually you have many type of game objects there. Sometimes in a game that you control your avatar to walk around, maybe you will meet the object. You can pick up the armor. You can pick up the armor. You can pick up the weapon. Also, sometimes it's portion. You can use that portion to heal yourself, to increase the HP or to increase your XP, something like that. Okay. So that's our different items are there, different objects, different kinds of objects there. So sometimes for those objects, they have a lot of features in common. right? Like if you are like a collision detection, maybe we want it to be the same. We want to set up a box or something, and we want if it's an object we want to be able to move it, or we want to move that armor, we want to move that weapon. As long as we touch them, we want them to move. Things like that, they have something in common, or maybe the gravity settings, they have something in common. However, there are some variables there you can manipulate to make a weapon, make a portion, to make the take the effect they are supposed to have the effect they are supposed to have. So at that time, one way is it's time consuming, but maybe it's easy to sync. Just we create script for each kind of item like that. We create a script for weapon. We create script for armor. We create script for potion. Right. So if we have a script for each individual item, yeah, that will work. And the problems is, first you have to implement some portion of the code again and again, and it's tedious, and then it's hard to manage, because if you want to modify a feature, you have to modify each of the script. So if you want to change the gravity of your all of the stuff in the environment, so you have to go through each of the item to change that code. Maybe sometimes you're missing one item is missing, and then that becomes a bug. So, but another way is we use a expandable item class. That's some sort of script. That's just a way of writing the script. However, in that script, you leave the space that you can configure. You can configure those variables in order to make that item, to make a weapon, right? So let's see. So we just need one script. Attach the script to different objects, but on different objects, we use different configuration of that script to make each object behave differently. That's our intention of creating expandable item class. Okay, before we're talking about that part, we have something else I need to explain. So this is the thing we're going to use today. And we can also shoot. We can walk around. We can shoot. But if we are shooting that cube 5 times, we should be able to destroy that. Okay, we destroy the cube. Yeah, you can shoot everything here, and actually this is hidden. So whenever this human hit any of the bullets, it actually reduce the health of that human as well. So, but it won't disappear because I didn't implement that. Instead, we can look at the console here. This line actually is the output of the health of that human. So whenever I hit one, now the current health is 20, and if I hit another one, actually the health is 0, and it output the game over. We can finish that function when game over. We can put another screen, see the game, something like that. And here I'm only using the you can see that there's a 20, and 0, and game over. That's output. Yeah, you can finish that functionality, but it's not necessary here to explain what we're going to talk. And first, let's continue off that topic. How can you create a projectile item? Okay. Let's look at here. So what we're shooting is this kind of bullet. Let's find this bullet here. Yeah, I believe it's this prefab bullet. So we create that prefab the same way. So here we have a bullet, and I don't think this is doing anything. Okay. It's actually yeah, for this bullet we have we're not using the expandable item class yet. So instead, this is a script that is specifically for the bullet. So as we can see here, on collision enter, what we are doing is, if we use that tag, we use the tag of a game object to detect what kind of game object are we hitting. So here, if we are hitting this enemy, we are going to first log we are hitting the enemy, output the information. That's for the debug. And then we reduce the health bar, and then we destroy the game object. We destroy the bullet. So whenever there's a hit, we destroy the game object, this bullet. And how can we do this? This enemy, we use a switch case here. So what we're used to judge is this game object's tag. So the object that has a collision with that, we use that game object's tag to detect what kind of object are we hitting. So here I believe we are setting this. Yeah. So if you select one of your object, you can use here. We have a drop-down menu here on the very top of the inspection panel. There's a tag, right? So inside the tag, maybe there's something there you can select already. So we have an enemy tag, we have environment tag, we have character tag. What is the tag? What the tag used to do is we are using the tag to kind of give a category to that game object. Because sometimes when we are using the tag to distinguish maybe the student from okay, we have a whole bunch of virtual human on campus. So we want maybe sometimes distinguish the student and the teacher. So we give a tag, right? Student. On your key card, I think it's student, faculty, things like that. Because sometimes we use that tag. Sometimes the student's behavior is different from the instructor's behavior. So when we're meeting in a class, the instructor standing here, the student sitting there. So that's different instruction. That's different behaviors. So we use the tag. You use the tag to distinguish what kind of object it is inside this thing. So here we want this cube to pretend as an enemy. So then we tag it as enemy. We tag it as enemy. And okay, it's enemy. And you can customize this tag. Here we have an 8 tag here. So you can hit this plus to create whatever tag you want it to be. Student, faculty, tables, chairs, whatever tag you want to use. So whenever we are using this tag here, in this collision detection, it's actually when we detect a collision, when we detect that something collided with that bullet, we do different reactions according to the category of that game object. So here, if that game object is tagged as enemy, case enemy, so it's a collisions game object tag. If that is an enemy, what we're doing is we reduce the health of that health of that enemy. And if it's hitting the character, okay, here the difference here. If it's hitting the enemy, we reduce the health of the enemy. And if we hit the character, it also reduces the health. However, what the difference is here in this environment. So if it is the enemy and the health is less than 0, we destroy that enemy. Okay, but if it's a character, we are not destroying the character. What we do is only here log. We output information, a game over information here. So that's a difference. That's a different behavior. So sometimes we don't want to destroy the game object, the character. But if we do, let me see if that's gonna happen. If we put the destroy here as well, do you think the character will be destroyed? Okay, let me shoot this. Okay, 1, 2, 3, 4, 5. Okay, it's gone. So that's how we play with that. But we don't want it to be gone. Okay, let's remove it. Or maybe it's good to make it gone. Okay, that's fine. And either way, it depends on your assumption to the game. Okay. Alright. So that's collision detection here. Yeah, we do the collision detection according to the tag of the object. So another thing here, maybe I don't know if you notice that here we're using on collision enter, but what we just talked is on collision detected, on collision, right? If you go back to the project 2, the chapter 2. So but now we're using on collision enter, right? On collision enter. So what's the difference here is, if you look at this, that bullet can actually get inside this cube. However, if we are using the usually, so in the real world, the collision is like my fist collided with this table. Right? There's no way I can get through it. Usually, there's no way I can get through it. Because it's gonna, we're gonna have a hit, and maybe something different happen. If it's a ball, maybe it's away to another place, going away to the other place. So that's another thing we need to simulate. But here, the collision can enter. So what we are doing is this. We're using a box collider here, and this is a bullet. If you see here, if we are hitting the wall, we actually don't have any. It's like a general collider. It's not going through that, enter that wall. Box collider. I should have this trigger checked, right? Let me see. Oh, it's a rigid body. Use the rigid body to control the speed. So we need that rigid body. Okay, so here what we defined is this on collision enter, and what we detecting that according to the tag. Yeah, I'm not sure here about the trigger part. Let me have more research on that. Okay, so let's continue. On the collision enter and destroy that item. Okay, that's good. And let's see how we actually gave a speed and initialize that bullet. Give speed and initialize the bullet. Projectile. Yeah, it's actually here. In this projectile, what we're doing here, it's the same. This part is the same. we instantiate that bullet prefab with the transform position X. So I believe this is attached to the character, I guess. Let me see. Yeah. So this is, since this projectile script is attached to the character. So here we're using the character's position X, character's position Y. However, we move it a little bit higher. We want it to shoot from the top of that character. And then we use the character's position Z. So we want it to shoot maybe a little bit in front of that character. So we basically we shoot wherever the character is, like a little bit off from there, in order to make it look better. And here we're using another statement here. Instantiated projectile dot get component rigid body. So what is a rigid body? A rigid body is something you are using to simulate some physics stuff, like the gravity or some force, to simulate some force. Like you apply a force to that cube, what's going to happen? Because that's going to be pushed and it's going to have some movement there. So it's basically like a physics engine inside Unity. So you can configure a lot of things here. In the rigid body, that's a mass, that's and use gravity, you can check it, uncheck it. And we have here freeze position, so it defines. Sometimes when you push that object, you want it just to ignore the force to some other direction. Just apply the force towards one single axis. You can use that to freeze the position. So anyway, just this rigid body is a physics simulation. It's a physics engine that provided to you. You can just configure and use. But for some advanced game, sometimes you want to implement your physics stuff. You want the physics reaction to be more accurate. You are free to do so. But this rigid body is provided already there, and you can use your own function to override some of its part, or you can just re-implement everything. So here we use this rigid body's velocity. One of the property in the rigid body is called velocity. So that's basically regarding the movement you can feel from this word, velocity. So when we give a velocity, what do? Is we use the transforms. It's a transform dot transform direction. Let's see. If we are not sure, transform dot so it's a vector 3. We use a vector 3 to assign that to that velocity. Here, we are actually combining the direction and the velocity in that vector. How can we do that? So if you think about a direction in the 3D space, for example, that direction to me. So basically, this vector, if you think my arm as a vector, so this vector can represent the direction of that axis sun, direction of it. So if I'm moving for this, along this vector, I'm gonna move to that side. Okay, and also we need a speed. So if you think about this vector, okay, if I reduce it like this, this is also a vector. It's also representing the same direction, right? So this direction is also going to that side. This is a vector going to that side. This is another vector going to the same direction. So, but the length of the vector is different. So here, what we're using is we're using the length of that vector as the speed, and we use the direction of the vector as the direction, so that we can initialize the projectile, and initialize the bullet's movement here. See here, we actually have a speed here. So we use that speed. The speed is set up here. Something you can, it's public, so you can just type in the speed you want. And projectile on this human. So this is 20. Maybe you can put it as 90. Let's see, something interesting will happen. It's pretty fast. I believe if we put 900. See, if we put a 900, you see what's happening? What's happening?
It's so fast it's not colliding with the box.
Yes, yes, exactly. If we set up it's very fast, right? If it's 900, it's a 900. So what the computer does is actually, we are shooting a projectile from here to hit this back. Right? This is frame 1, the frame 1, the projectile, the bullet is here, frame 2 is here, frame 3 is here. Okay, frame 4 is somewhere in the box, so there's a collider we can detect. However, it's moving, it is moving very fast. Frame 1 is here, frame 2 is here, so it's skipping that object, so the collision won't be detected. So that's a problem of that collision detection. However, we can set it something like a continuous detection. Let's see if that will work. Okay, that's just I want to try it because most of the time I'm using this discrete, and I assume that this continuous will work, but obviously there needs some other configuration here. Yeah, so let's stay on this discrete. Okay, so you cannot make it too fast, otherwise this hit is gonna be a problem. Okay, if you're using this discrete collision detection. However, I do think this continuous will work. Maybe I need to check how to make that continuous work here. But that's another way of detecting collision. So it's not calculating each frame, it's just calculating the path. So if you implement it yourself, not here, it's calculating the path of it instead of where is it in each frame. So it's gonna be more accurate. And now let's change it back. That's not what we are going to talk today. Yeah. Yes. So the collision detection. And let's look at this item melee, item range, item self. Those are not the classes used here. So here we have this cube here. We have react to define how should we react to that collision in this cube. Okay, and then here we also use some other script here to define the reaction. However, here this is something we do want to talk. This is a script. The style of the script is the expandable item. So let's see here what is here. So first we need to know how can we define some of the enum type. So melee action, we can buff, debuff stuff, change HP, activate an environment, and this melee type can be weapon, portion, none. So if we define here, wherever we're using it, like this public melee action, here we can actually, if you hit the drop down menu, what's gonna happen? Since we define it here, we define this melee action here, we have this 4 type of action, and then we define the public variable here. If we use the drop down menu, what's gonna happen? Yeah, you will have these options available. Let's see. What? Yeah. Okay. So if we actually have a melee item, here, so you can see melee action. If we hit drop down menu, we can have a way to set up its action here. And if we have something else, like we just call it something else. And inside the drop down menu, come on, you should have this something else here. So that's how you use this enum. Let's remove it. Okay, and after we set up its melee action, its type, then we can do some of the behaviors according to its type. Like here, case, not here. And yeah, so we are using this type to make some judgment for different reactions. We can talk about it next in the next class. But on Thursday it's gonna be lab. So please look at your D2L announcement, which group you are in, and what is the room number of the lab. Okay. All right. Thank you very much. I'll see you on Thursday.